Hello viewers, welcome to my channel BioQuest Biochemistry classes. Today I am back with a video tutorial on laboratory instruments. To start with, today we will have a short discussion on centrifuges. Let us check what are centrifuges and their working principle. The equipment used to perform centrifugation is called centrifuge. Centrifugation is a separation technique commonly used in clinical and research laboratories. It is based on different rate of sedimentation in a centrifugal field. Particles that differ in density, size, or shape have different sedimentation rate. Now, let us look at this figure. In this figure, you can see that this vertical line, this is nothing but the motor. And from this motor, you can see these two blue holders. They are nothing but the rotors where samples or tubes that are used for centrifugation are kept. This purple color line, it indicates the centrifugal force, which by definition acts away from the axis of the rotation or center of rotation, and this red color line represents the axis of rotation. The black color line is the force of gravity. Now let us check what happens actually in centrifugation that makes the substance to settle down. The basis of centrifugation is to exert a larger force than gravitational force that will enhance the effective sedimentation force for separation. The rate at which sedimentation occurs in centrifugation is expressed in weight-work units. You can recall that the molecular weight of prokaryotic ribosome is expressed as 70S, whereas in eukaryote it is expressed as 80S. This S are nothing but the sedimentation coefficient of the ribosome, and it stands for weight-work units. What are the parts of a centrifuge? A centrifuge consists of a lead, panel of buttons, digital display, motor and rotor to hold the tubes. This black part is nothing but the lead of a centrifuge, and this is the digital display. It consists of this button, that is the on off button. Next we have the button for the RPM setting, which is nothing but RPM stands for revolutions per minute, and this one is the timer button. That means the preset time for how long the centrifugation will continue. The arrow, the triangles upside down and the normal triangle, they are used either for decreasing or increasing the speed of rotation or the timing that is required for centrifugation. Now, the rotors which are inside the centrifuge that are at a fixed radius away from the motor, they are either made of aluminium or titanium alloys. Each of them have their advantage. Aluminium is pocket friendly, that it is less costly, whereas titanium is more resistant to erosion by corrosives, acids or temperature. Each centrifuge is provided with a nomogram. Whenever you check for the box with which the centrifuge has arrived in your lab, you will see that that is provided with a catalog that is known as nomogram. The nomogram somewhat looks like this. So here in one panel you will have the RCF, that is the relative centrifugal force, and there is the speed which is expressed in RPM. So it is used for interconversion between RPM and RCF. In some of the SOP, the speed is given as RCF expressed as small g. In some of the SOP, it is given as RPM. This equation converts the RPM to RCF or vice versa. It is calculated by the formula RCF equal to RPM whole square into 1.18 into 10 to the power minus 5 into R, where R is the radius at which the rotor is located away from the motor. The performance of centrifuge is judged by a tachometer. According to the maximum RPM, centrifuges can be classified into three types. Low speed or benchtop centrifuges. They can attain a maximum RPM of 4,000 to 6,000. High speed centrifuges. They can attain a maximum speed within the range of 15,000 to 25,000 RPM, and the ultra-centrifuges 70,000 to 80,000 RPM. They are mainly designed for extraction of cellular organelles, and they are also known as refrigerated centrifuge or commonly termed as cooling centrifuge, because a huge amount of heat will be generated with this speed. So a cooling chamber is provided with this type of centrifuge. That's why they are also known as refrigerated centrifuge. According to the types of the rotor, the rotor may be of three types. First category, that is the vertical axis rotor, where the rotor is lying parallel to the axis of the motor. Second one is the fixed angle rotor, where the rotor lies at an angle of 45 degree fixed to the centrifuge. And the third one is the swinging bucket rotor. Initially, it is lying parallel to the motor, but as soon as it starts rotating, it will shift at a position perpendicular to the motor. So this is the swinging bucket rotor. Let us check the uses or application of centrifuge in the laboratory. Separation of serum, plasma and erythrocytes from clotted blood, anticoagulant added blood and oxalated or heparinized blood respectively. It is also used in the estimation of packed cell volume or hematocrit values. It is used in isolation of cell organelle or in subcellular fractionation. Preparation of platelet poor plasma. Determination of molecular weight by studying their sedimentation characteristics and coefficient. Let us check the SOP of centrifuge. SOP stands for Standard Operating Procedure. So what are the steps? Ensure that the centrifuge is placed on a rigid, flat, level surface. Open the lid of the centrifuge and insert samples into the rotor with proper balancing. What is balancing? Balancing is placing two samples diagonally opposite of each other, preferably having equal volume. In this figure, you can see that the samples in the rotor are placed just diagonally opposite, blue to blue orange to orange. So this is how the setup of sample should be done. This is known as balancing. If there are odd number of samples, then we should counterbalance with tube filled with equal volume of water. Close the lid. Now we have to select the appropriate RPM and time required for the separation and switch on the start button. Once the centrifugation is over, wait for a few minutes. Open the lid, take out the samples. So, this is the standard operating procedure of centrifuge. This is a common question repeated many a times in various DMLT and MLT examinations. Switch off the main switch and get the separated sample you want from this procedure. If you like the video, do give it a thumbs up and like, share and subscribe the channel. Thanks for watching. Keep watching.